Unit 6, Characteristics of a Good Research Tool. 6.1 Introduction. Data collection is an important part of research. In order to collect the requisite data for any theme of research, you have to devise an appropriate design, use suitable measuring techniques, and decide on the relevant attributes of the sample drawn. There are several research designs and tools, varying in operations, complexity of features, and interpretation. In this unit, we will learn about the characteristics of a good research tool. Objectives. After studying this unit, you will be able to understand tests and their types, explain the characteristics of a good research tool, and describe scaling in research. 6.2 Tests. With the help of tests, we can collect quantitative data in research. There are different types of tests. It was the English biologist Sir Francis Galton who was primarily responsible for launching the testing movement. In an article written by Cattell in 1890, the term mental test was used for the first time. Psychological testing is a relatively young branch of one of the youngest sciences. 6.1. What is a test? A test is a systematic procedure for observing a person's behavior and describing it with the aid of a numerical scale or a category system. A psychological test is essentially an objective and standardized measure of a sample of behavior. 6.2 Types of tests. Tests are classified in different ways. Classification of tests by function. 1. Educational tests, achievement and diagnostic. 2. Personality tests. 3. Aptitude tests by nature. 1. Speed tests. 2. Power tests. 3. Verbal tests. 4. Nonverbal tests. 5. Performance tests. 6. Standardized tests. 7. Culture fair tests. 8. Adapted tests. By procedure of administration. 1. Group tests. 2. Individual tests. Let us now understand the meaning of this classification. We will also get detailed information about various tests. 1. Classification of tests as per their function. Depending on what a test aims to measure, the tests are classified into the following groups. I. Educational tests. Certain types of tests are developed for use in educational contexts. They include achievement tests and diagnostic tests. Achievement tests. These are designed to measure the effects of a specific program of instruction or training. An achievement test measures the effects of relatively standardized sets of learning experiences. It generally represents a terminal evaluation of the individual's status upon the completion of an instructional program or training. An achievement test measures developed abilities or skills. Diagnostic tests. These are designed to analyze an individual's specific strengths and weaknesses in a subject and to suggest causes of their difficulties. In connection with the use of all diagnostic tests, one point deserves special emphasis. The diagnosis of learning disabilities is a prerequisite for a program of remedial teaching. Personality tests. These most often refer to measures of affective aspects of behaviors such as emotional states, interpersonal relations, motivation, interests, and attitudes. A personality test could be 1. A self-report inventory, 2. A situational test, or 3. The application of a projective technique. EI, aptitude tests. These measure the effects of learning under relatively uncontrolled and unknown conditions, compared to achievement tests. They include 1. General intelligence tests, designed to measure the intelligence of an individual. Here, we must bear in mind that intelligence is not a single, unitary ability, but a composite of several abilities. The term is commonly used to cover a combination of abilities required for survival and advancement within a particular culture, e.g., Stanford Binet Test of Intelligence. 2. Multiple aptitude batteries. Yield a profile of test scores in a set of relatively independent abilities identified through factor analysis. One of the most widely used multiple aptitude batteries is the differential aptitude test, DAT. This DAT yields scores on 8 abilities: verbal reasoning, numerical ability, abstract reasoning, clerical speed and accuracy, mechanical reasoning, space relations, spelling, and language usage. 3. Creative aptitude batteries. These have been produced at the University of Southern California by J.P. Guilford and his colleagues and include tests of creative thinking by Paul Torrance. Tant 2. Classification of tests as per their nature. Speed tests. Speed tests contain items of somewhat equal difficulty. To solve these tests, the time limits are strictly fixed, such as in usual school or college tests. 2. Power tests. Power tests contain items of varying difficulty, arranged in increasing order of difficulty. For such tests, the time limit is not fixed and is flexible. Verbal tests. Verbal tests include question-answer patterns in the form of words. Such verbal tests can be either paper-pencil, written tests, or oral tests. IV. Nonverbal tests. Nonverbal tests contain items in figural or symbolic form other than words. Raven's progressive matrices test is an example of a nonverbal test. V. Performance tests. Performance tests require some action on the part of the respondent as their response. Bhattia's intelligence test is an example of a performance test. V. Standardized tests. Standardized tests imply uniformity in the procedure for administering and scoring. Another important aspect of standardized tests is the establishment of norms, reliability, and validity of the tests. Criterion-referenced tests. These tests are contrasted with norm-reference tests, in which an individual's score is interpreted by comparing it with the scores of others in the group on the same test. In a criterion-reference test, an individual's score is interpreted by comparing it with an external criterion, such as 80 by 80 mastery level. Culture fair tests. Culture fair tests presuppose only such experiences that are common to different cultures. The terms culture fair, culture common, and cross-cultural are used synonymously and have replaced the term culture free. Adapted tests. Adapted tests are versions of tests standardized in other countries with dissimilar cultures, modified to suit the culture under consideration. 3. Classification of tests as per the procedure of administration. Group tests. Group tests are designed as mass testing instruments. They permit the simultaneous testing or examination of large groups. The instructions and administration procedures are simplified to require minimal training for the test administrator or examiner. 2. Individual tests. Individual tests are administered to one person at a time. Considering the testing situation, including responses in the form of actual performance, the observer records the entries in the performance sheet for one candidate at a time. 6.3 Characteristics of a good research tool. The characteristics of a good research tool are discussed below. 6.31 Validity. A good research tool must measure what it is supposed to measure. A test is valid if it meets the purpose for which it was designed. Validity is fundamental. It can be categorized as high, moderate, or low. Furthermore, validity is specific. A test may be valid for one purpose, but not for another. 6.3.2 Reliability. Reliability is the consistency of a measuring instrument. A reliable test measures accurately and consistently. If a reliable test is administered 2 or 3 times to the same group, each individual should get approximately the same score on all occasions. Reliability is a statistical concept and is expressed using a correlation coefficient. 6.3.3 Objectivity. A test is objective when the examiner's personal judgment does not affect the scoring. Objective tests include multiple choice, matching, and true-false items. Objectivity is a prerequisite for reliability. 6.3.4 Adequacy. A good research tool must be adequate. It should measure the required aspects comprehensively, but not assume it measures everything a pupil has acquired in a school course. Adequacy supports both reliability and validity. 6.3.5 Usability. The usability or practicality of a test is crucial. The most valid test will not help if it is not used. Factors affecting usability include ease of administration. Directions for administering the test should be simple and clear. Ease of scoring. Scoring should not require complicated algebraic manipulations. Ease of interpretation. Test results must be easily interpretable for successful application. Economy. Tests should balance cost-effectiveness and quality. Economy also includes the time required for administering and scoring. Availability of equivalent forms. Equivalent forms measure the same behavior using similar items, aiding research purposes. 6.3.6 Discriminating power. A test discriminates well when it is constructed in such a manner that it detects or measures small differences in achievement and identifies the good from the poor. This quality of a test directly affects its validity, making it an essential criterion for selecting a data collection tool. 6.3.7 Interest. Tests that are interesting and enjoyable help gain the cooperation of the subject. Under unfavorable conditions, the test is unlikely to yield useful results. Hence, from among the available options, the tool that satisfies all other criteria and is also interesting should be selected for data collection. 6.3.8 Norms. Norms represent the test performance of the standardization sample. They are empirically established by determining what individuals in a representative group actually achieve on the test. Norms, by converting raw scores into derived scores, are expressed in two major ways: A, developmental level attained, and B, relative position within a specified group. Examples of developmental norms include age norms and grade norms, while percentiles and standard scores are examples of within-group norms. There are three main characteristics of a good research tool: validity, reliability, and usability. When selecting tools for collecting data, researchers should evaluate them based on these criteria one by one. The existence of norms is crucial for practical application at the field level. Validity. The validity of a test concerns what the test measures and how well it does so. All procedures for determining test validity focus on the relationship between test performance and other independent, observable facts about the behavior or characteristics under consideration. A tool used for collecting data must provide information that is both relevant and free from systematic errors. In other words, it must produce valid information and measure what it claims to measure. For example, an achievement test in physics must measure a student's knowledge of physics alone and not inadvertently assess language ability. If a question on frictional force is asked and a student well-versed in English writes an excellent essay on it, the researcher should ensure they are measuring the student's understanding of frictional force and not their language skills. A tool does not possess universal validity. It may be valid in one situation, but not in another. Instead of asking, "Is this research tool valid?" it is more relevant to ask, "How valid is this tool for collecting the specific information the researcher needs?" Or, "For what decision is this tool valid?" There are three types of validity. 1. Content validity. 2. Criterion validity. 3. Construct validity. Content validity. Content validity relates to the relevance of a research tool's content to the objective and nature of the research problem. Content validation involves systematically examining the test content to determine whether it covers a representative sample of the behavior domain to be measured. For example, in the case of achievement tests, content validity is assessed by evaluating the relevance of test items to instructional objectives, the actual subject studied, and the knowledge acquired. Collectively, the items should represent the variable being tested. The content validity of a research tool is based on judgments by several experts in the field concerned, careful analysis of the objectives of the research subject, and the hypotheses, if any, to be tested. Content validity is also known as rational validity, logical validity, or face validity. Criterion-related validity. This has two subtypes: predictive validity and concurrent validity. Let us take a closer look at each of these. Predictive validity. If a test is designed to identify good candidates for appointment as teachers, and test scores show a high positive correlation with actual performance on the job, the test has a high degree of predictive validity. Thus, predictive validity refers to the usefulness of a test in predicting some future performance. It is particularly important for aptitude tests. Concurrent validity. The coefficient of correlation between the test scores and scores on another test or measure of known validity is the concurrent validity of the test. If both tests are similar, e.g. creativity tests, it is referred to as convergent validity. In contrast, if the tests are of different types, it is referred to as discriminant validity. In decision-making situations, selection or classification is based on an individual's expected performance as predicted by a research tool. For example, a psychological test or rating scale that predicts the kind of behavior it was intended to predict is said to possess predictive validity. The prediction may concern success in a job or a course. This validity refers to the association between present results, as indicated by a particular research tool, and future behavior. To determine the predictive validity of a tool, the results must be compared with actual performance or outcomes in the future. For instance, if a test is designed to select students for a medical course, the scores must indicate a significant positive relationship with their ultimate success in the medical profession. A researcher studies predictive validity if their primary interest lies in the outcome they want to improve through professional decisions. In some research situations, a researcher may wish to develop a new tool as a substitute for an already existing cumbersome tool, technique, or method. If the existing tool is considered useful for decision making, the key question is whether the new tool agrees with the information sought through the existing tool. If they disagree, the new tool cannot be substituted for the original. The agreement between the newly developed tool and the already existing tool is estimated through empirical comparison. Both tools are applied to the same sample groups, and the results are compared. This empirical check is called concurrent validation, as the information obtained through both tools should yield nearly the same results. The validity of the new tool thus established is called its concurrent validity. For example, if a researcher develops an achievement test in mathematics, the scores on this test can be compared with scores given by a mathematics teacher to the same students. If the two tests show nearly the same results, the concurrent validity of the newly developed tool is established. In the case of predictive validity, the measure of the outcome is termed the criterion. When estimating concurrent validity, the newly developed tool is proposed as a substitute for the existing method, and the information obtained through the existing method acts as the criterion. Since in both cases the information sought is related to a criterion, these two types of validation are also termed criterion-related validity. Construct validity concerns the extent to which a test measures a specific trait or construct. It is the degree to which scores on a test can be explained by the explanatory constructs of a sound theory. For instance, if one were to study a construct like originality, one would hypothesize that individuals with this characteristic will perform differently from those who do not. Theories can describe how people with originality behave in a distinctive way. If such individuals can be identified by observation and rated based on the theory, a device can then be designed. A device has construct validity to the extent that the scores on it systematically relate to judgments made by observing behavior identified by the theory as possessing originality. This type of validity is essential for tests used to assess individuals on psychological traits and abilities. Examples of common constructs include anxiety, intelligence, motivation, attitude, and critical thinking. Construct validity is established by relating a presumed measure of a construct to some behavior hypothesized to underlie it. Reliability. In psychometrics, reliability refers to consistency. Test reliability is the consistency of scores obtained by the same individuals when retested with identical or equivalent forms of the test. A tool used for data collection must be reliable, meaning it should consistently yield the same results under the same conditions. Here is the corrected. For example, if an individual records his or her responses on various items of a questionnaire and thus provides a certain type of response, she should provide similar responses when the questionnaire is administered to him/her on a second occasion. Likewise, if an achievement test is administered to learners and then re-administered after a gap of 15 days, without any special coaching in that subject within these 15 days, the learners must show a similar range of scores on the re-administration of the test. Repeated measurement of an attribute, characteristic, or trait by a tool may provide different results. These differences may be due either to a real change in the individual's behavior or to the unreliability or inconsistency of the tool itself. If the variation in the results is due to a real change in behavior, the reliability of the tool is not to be doubted. However, if the variation is due to the tool itself, then the tool is to be discarded. There are various procedures to assess the reliability of a tool. These include I, the test-retest method, T, the alternate or parallel form method, I, the split-half method, IV, the rational equivalence method, the test-retest method. Test-retest reliability. A test is administered to a sample on two different occasions with some interval in between. The correlation between the two sets of scores is the reliability coefficient. It measures the extent to which scores on a test can be generalized over different occasions. In this method, the same tool is re-administered to the same sample of the population shortly after its first administration. The relationship or agreement between the information or data sought through the two administrations provides the measure of reliability of the tool. The chief disadvantage of this method is that if the time between two administrations of the tool is short, the immediate memory effects, practice, and the confidence induced by familiarity with the tool may give a false measure of its reliability. On the other hand, if the interval is too long, the real changes in behavior in terms of growth may underestimate the reliability of the tool. Owing to these limitations, the test-retest method is generally less useful than other methods. However, this type of measurement is commonly used with questionnaires, observations, and interviews. The equivalent or parallel forms method. Alternate form reliability. Pertaining to the objectives, two parallel tests are constructed and administered to the sample with some interval in between. The correlation between these two scores is the reliability coefficient. It measures both temporal stability and consistency of response to different item samples. This method requires that two equivalent or parallel forms of the tool be prepared and administered to the same group of subjects. The items in these tests are parallel. Then, the results, in terms of two sets of measures obtained by the use of the tool, are correlated to measure the level of its reliability. In developing the parallel forms of a tool, care must be taken to match the tool material with the content, difficulty level, and form. The parallel form method is widely used for determining the reliability of a research tool. The reliability of psychological tests and attitude scales is usually estimated by this method. The split-half method. Split-half reliability. The procedure to establish split-half reliability involves a one-time administration of the test. The scores obtained by the sample are grouped into two sets. This grouping is mostly done by separating the even items into one group and the odd items into another for every candidate. Thus, we get a pair of total scores for each one. The correlation between those two scores is the reliability coefficient. It measures the internal consistency of the test. In this method, the tool is first divided into two equivalent halves. If there are 60 items in a test, two equivalent halves are made of 30 items each. This may be done by alternating items. The measure of the first half of the tool is correlated with the measure of the other half. The measures are correlated to find the reliability of tests and attitude scales. The main limitation of this method is that a tool can be divided into two halves in a number of ways, and thus the estimate of the reliability may not have a unique value. The rational equivalent method. This method of measuring reliability is considered free from the limitations of the other methods discussed so far. Two forms of a tool are defined as equivalent when their corresponding contents are interchangeable. This method is most commonly used in estimating the reliability of psychological tests. Note, a valid test may be reliable, but a reliable test is not always valid. Hot 6.4 Use of scales in research. Research tools are measuring devices. Every measuring device has some kind of gradation, depending upon the system of measurement. For example, the FPS or CGS systems measure length in feet or centimeters. Similarly, weight is measured in pounds and grams. A foot rule that measures length is marked in inches. There are two major attributes. 1, each inch is of equal length wherever it appears on the foot rule. 2, two different objects measured as 2 inches by the same foot rule are of the same length. Just as FPS or CGS provides the basis for scaling physical measurement, it is necessary to provide certain forms of scaling for mental measurement. Measurement of variables like intelligence, achievement, demographic attributes, etc. 4 types of scales are used in psychological measurement: nominal, ordinal, interval. Nachter 6.41 Nominal scale. This is the most elementary form of scale. As indicated by the name itself, it is only nominal. This scale is largely used to classify people or objects into certain categories, such as male-female, rural-urban, dark-light, tall-short, etc. In other words, it labels the object of measurement. In research, it is concerned with the frequency of occurrences in various categories. For example, in a class or counseling session, how many are male or female students, or how many have read the learning material or have not read it. 6.42 ordinal scale. This is the second level of scale, more sophisticated than the nominal scale, though still relatively crude. When the sample of the research is arranged in ascending or descending order based on data on a variable, we are using the ordinal scale. For example, the 10th rank in a class of 60 students is better than the 11th rank, but lower than the 9th. However, despite the ranking, it does not show the difference between the 10th and 9th. In other words, the differences between the ranks are either unknown or unequal. The only information derived in this case is the relative position of a subject within the sampled population on a variable. Hash 6.4.3. As the name indicates, a scale that has intervals at different points of gradation is called an interval scale. This is also called an equally appearing intervals scale. The most common use of an interval scale is the achievement test when the test contains 100 as full marks. It implies 0 as the beginning, making it a 0 to 100 point scale graded by one score at a time. This form of scale is extensively used in studies of psychological variables like interest, attitudes, and aptitude. Although it is the most sophisticated scale in social research, it has the limitation of being inexact compared to ratio scales used in physical measurement. 6.4.4 Ratio Scale. A ratio scale is primarily used in physical measurement. It is exact and accurate. It is very similar to an interval scale, except that it has an absolute 0. For example, if a length is indicated as 0 centimeters, it means non-existence, whereas a score of 0 in mathematics does not indicate the absence of mathematical knowledge. The other major feature of a ratio scale is the ratio itself. It implies that in a 100 centimeters or 1 meter long rod, the distance between the 28th and 30th centimeters is exactly equal to the distance between the 88th and 90th centimeters. In this case, the intervals in the scale are not apparent but real. Although the ratio scale has little application in social research, its basic philosophy underlies the interval scale, which is extensively used in counseling and family therapy. To summarize, there are 4 types of scales: nominal, ordinal, interval, and ratio. The nominal scale and ratio scale are at the crude and sophisticated ends of the continuum, respectively. The most extensively used scaling technique in social science research is the interval scale. However, the choice of scaling technique depends upon the nature of the variable to be studied. 6 marks. In this unit, we have provided information about scaling in research. We studied that there are 4 types of scales: nominal, ordinal, interval, and ratio scales. The nominal scale is the most elementary form of scale. As indicated by the name itself, it is only nominal. The ordinal scale is the second level of scale, which is more sophisticated than the nominal scale, though it remains one of the cruder forms. The scale that has intervals at different points of gradation is called the interval scale. The ratio scale, as mentioned above, is primarily used in physical measurement. It is exact and accurate. We have also studied the validity and reliability as characteristics of a good research tool. There are 3 types of validity. 1. Content validity. 2. Criterion-related validity. 3. Construct validity. There are various procedures to assess the reliability of a tool. These include 1. The test-retest method. 2. The alternate or parallel form method. 3. The split-half method. 4. The rational equivalence method. We have also learned about tests, their different types, and the basic characteristics of a good test. 6.6 Glossary. Construct validity, the degree to which scores on a test can be accounted for by the explanatory constructs of a sound theory. Criterion-related validity. It refers to 2 types of validity under different time frames. Reliable. A tool must have the ability to consistently yield the same results for individuals under the same conditions. Test, a systematic procedure for observing a person's behavior and describing it with the aid of a numerical scale or a category system. A tool used for collecting data must provide information that is not only relevant, but also free from systematic errors.